Hello learner, greetings of the day. Let us discuss about an important concept here, that is display list. Let's begin with the concept of clients and server. So as we all know, what is a client? What is the role of a client and a server? So a server is the one which always is ready for serving the clients. So clients are the one who always makes a request. So servers are the one which always provides the service back to the clients. So you can just see this block diagram. Here you can see various servers are connected to through a network, so connected through a LAN or something. So you can just see here a print server, compute server, file server, workstation, several workstations where several clients may be attached, several clients may be working there. And you can see here a special server and you call it as a graphics server. So this server is mainly here, you can say its main role is to provide service to the users who are requesting for graphical output, so are requesting for graphics, maybe 2D graphics or 3D graphics. So here it's at workstation, several clients may be working and clients may be requesting here in the form of a program. And what type of program here we are concentrating on? It is the OpenGL program. So here user requests in the form of an OpenGL program. He writes an OpenGL program, the request is made, and now the request is sent to the remote graphics server. So here it is this graphics server we are speaking about, and this is a client server architecture that is followed here even in graphics. So what is the display list we are speaking about? So just recall about the basic graphic system. So basic system, so we have a host where a client is sitting and working, and the host is requesting for the data or whatever the input he requires or whatever the output he wants to display, that will be sent to a display. So you can say the data is sent to the display directly to which is finally displayed on the screen. And nothing called as storage over here, as in when the user writes a program here, the input is maybe received and from the input device and the output is sent to the screen. So nothing is saved anywhere. You can just see an improvement or advancement to this system here. In between the host and the display system, there is something called as a processor and there is something called as a display file. What is it? So a processor is added. So what is it? It has a computation that is happening in between, and also it has a memory to save the things. So user writes a program, and whatever he has planned to display on the display, so whatever the primitives he wants to display, whatever the graphics he wants to display, that graphics can be manipulated or that graphics can be saved or stored here in the memory. So that storage part here, you can call it as this display file, a small file which is containing the contents, that which is actually containing now the contents that has to be displayed on the final display. Okay, host, instead of sending the contents directly onto the display, we have a storage here in order to store that contents that has to be displayed, so that whenever the user wants to redisplay the contents, rather than again writing the program or again executing the program to display, okay, what he can do, the host can simply take off this file and display the contents of that, run that or send that to the display, so that recomputation is the time taken to recompute it is saved, right? So the computational complexity is saved. So if it is a simple graphics, then no need of such display file, but if it is complicated graphics that you're displaying, if lot of computations is required in order to display, then it's highly inefficient to re-execute the entire program or recompute the entire thing there in order to display the graphics. So in that case, we save the contents, display contents in the form of a small file, and that file is re-execute. In order to re-execute, that file is retrieved and then it is sent to the display. So that is an advantage here. So here we can say that this display processor, whatever we have, it is actually the modern graphics server. Okay, so the user program that we have, it is actually a client. So we write an OpenGL program that acts as a client, and the display processor acts as a server there. So here we incorporate client server architecture. Okay, and now here this how we can send the entities, graphics or graphical entities to display, that is from the user to the final screen display system. How we can send the graphical entities? It can be sent in two modes. One is immediate mode and the other one is retained mode. We will see that. The first one is immediate mode. So what is this immediate mode? You can just see here. In immediate mode, the primitive in the sense the graphics. So suppose I want to display a line. So if I have to display a line, I have to send the endpoints and the corresponding color of the line to be displayed. So all these are the contents like that I have to send to the final screen, that is display window. So the primitive that is to be sent to the server or the processor here for display, and if I have no memory of that is retained, that means I'll not store that contents here in my memory, that is in the display processor. Instead of simply storing there, I will simply redirect the contents directly to the display. I will not store anything. So what is going to happen there? If at all I want to redisplay the line next time, first time I am displaying directly, not an issue, but second time when I want to redisplay, since I have no backup of the contents, I have to again execute the entire program, again the computation has to be made, then again those two endpoints should be sent, and then I have to send the line. Like we have already seen the Bresenham line generation algorithm. So where we have to do a lot of computation to generate the points, to finally display the line. So all that computations has to be re-executed in order to generate a simple line. So that is happening here. So that is in the case of complex objects. This is highly you can say very inefficient technique, immediate mode. Suppose if we have now the next mode, that is the retained mode. So what is retained mode? Here we will retain the things. Rather than directly sending the contents to the display, I will store that contents. I'll have a backup of that contents in the form of a display list. So what is a display list? It is nothing but a small file, like I already said, and that file will contain only the primitive information. What is primitive? It is only the graphics contents what I am displaying finally, that contents will be stored in this file. So suppose if I am drawing a line like end points, then color, and all the points that I am generating on the screen, that information is stored in the file. So that file will be stored here in the server, here in the server, and that content will be redisplayed just with the help of a simple function call. So redisplaying the contents is happening just with the help of a simple function call here. So you need not re-execute the entire program, so need not go with the recomputation there. So directly you retrieve the content or retrieve this display list, retrieve this simple file, and redisplay the contents on the screen. So advantage is make good use of a hardware, that is you are making use of this server. And then disadvantage is your memory will be you are accessing the memory there all the time, so your memory will be used up. So server is accessed every now and then. You have to make a request to the server every now and then. So if you are creating multiple such files, multiple such display list, it may create a overhead. So we will see now what exactly is a display list. As I already said, a display list is nothing but a common file. It is just an ordinary file. So here the file, when I say, it is a small file here which is very flexible. You can go on adding the things onto this file easily. You can define the file, you can create the file, as well as you can go on adding the things to this file, and also at any time you can manipulate the file. So file is a simple file, you can create it easily, you can define the file, then you can go on adding the contents to the file, and also can delete or manipulate the file. So handling such display list or in the form of a file is very easy. So OpenGL has a very few small set of functions to create this display list, to generate this display list, or to delete this display list, to execute this display list, manipulate this display list. Small function calls you have to make using OpenGL there. So we will see several examples of this display list. Let's see the structure of display list now. We have the display list structure here. See, every display list must have a unique identification number. So what is it? Suppose here I am displaying multiple primitives, and each primitive contents I will store in the form of a display list. So suppose I want to first draw a line. Also next I want to draw a polygon. Okay, a polygon I want to draw, and then I want to draw a circle or something, right? So here these are the three primitives that I want to draw. So what can I do over here? I can create one display list for line, I can create the second display list for polygon, third display list I can create for circle. So whenever I want to redraw the polygon, I can just call this display list, just retrieve this display list. But how do I retrieve, how do I identify these three different display lists? It is with the help of this unique identification number. So for each such display list, you give or assign a unique identification number, and you can just see here where is this display list stored. Always this display list is stored here in the processor. Okay, this you call this processor as a graphics server. So in the graphics server you store this display list in the form of a file. So here you can just see the structure of display list. First I will just use one unique, I'll just use a name here to identify easily my display list. Say suppose I'm displaying a polygon now, I'm creating a display list for this polygon. Okay, so I'll just name this as box. I'll just name this display list as box, and the ID that I'm assigning for this is 1. So anymore when I use the term box, the ID 1 will be replaced there. Okay, so or you can say the ID 1 is a unique identification number assigned for this display list, and the name that we have given is box. So here I'm using a function, OpenGL function GL new list. So this is an OpenGL function to create a display list. So here I'm creating the display list, I'm assigning the name, that is box, and the ID will be automatically replaced here, that is 1, and I'm using a mode called GL_compile. Remember, these parameters should be in all caps. So this parameter GL_compile says that send the contents, create the display list, send the contents to the server, and then store that contents here in the form of a display list. Store it here, but do not display anything on the final screen display window. So don't display anything, just store it in the server. So that is what is this constant GL_compile says. We can just now see here the compilation is clear, that is just store the contents here in the display processor or in the server, but do not display anything. That is the meaning of GL_compile. And then we have here as usual the snippet, that is GL begin, GL polygon, then assign a color to the polygon, then define the 4 vertices of the polygon. This is as it is. Then define GL end. So how to end this display list? You call GL end list. So we have seen 2 new OpenGL function, that is GL new list and then GL end list. These are the functions to create the display list. So remember, this GL_compile is to store the contents in the server, but do not display anything on the screen. So this is how you create the display list. Like if we want to display the display list contents immediately after I generate the list. So immediately after I generate the list, the moment I call this generated list, if I wanted to execute, then I need to pass a parameter there, and that parameter is, instead of gl compile, it is gl compile and execute. Like we have already seen in the previous slide, gl compile is the one, it is just says that as soon as it is generated, don't execute but just save it in the server. But if here, instead of gl compile, if you give gl compile and execute, it will it will just say that you generate the list, and then immediately after generating the list, you can execute the display list. So we have a OpenGL function to execute this generated display list. See, as we have already seen, gl gen list is the one function which is used to generate the list, and then gl new list is the function which is used to create a new display list, and then that created new display list can be executed by calling gl call list. And remember to pass the id of the display list, and as we have already seen, id of the display list is one which is named as box there. So this is the name of the box display list, which can be used as an index here for executing the generated display list. So after that, we will just see here few other OpenGL functions, extra OpenGL functions. See, it is something like, see, if I have set the current drawing color as red, okay, and if that current drawing red color, if the drawing color is red and if it is still in effect, so that means current drawing color is red, then in all the display list that you have created, this drawing color will be set to red. So it is something like, if you have already set a color using gl color function, and if the color set, what you have set as red color, and suppose before creating the display list you have not changed any color, then the same drawing color red will be continued for all the display list. So in that case, what can you do there? We can just save the attribute. So this current drawing color, whatever you had till you created the display list, okay, till the display list with this function. So what is it? gl push attribute. So gl push attribute will save all the attributes just before your display list creation. All the attributes, say for example, one of the attribute is color, so the color that was set to red will be saved in the stack. So push attribute gl all attribute bits. So the color, maybe it is one color, or maybe the line style if you have used, so size, if you have used line size or point size, all those attributes will be pushed into the stack, it will be saved in the stack. So you call the function gl push matrix, so which will be saving the contents into the stack, and after that you can now create your display list, and for your new display list that you have created, you can set a new color, okay, so the new attributes you can set for it. And after your display list is completed, then you can come back to the old state. What is that? Your earlier, that is before creating the display list, your current drawing color was, your drawing color was red, so you can set back that drawing color by just popping those attributes, or pop matrix is the function which will pop all the contents from the stack. So that means you are restoring the previous state, previous to display list generation. Okay, so this also is possible in display list. So before display list creation, all the previous attributes you can save in the stack, and after the display list is created, for the display list you can set all new color and new attributes, and then after the display list is created, you can restore the previous state by popping the attributes and popping the matrix. These are some of the functions that we make use in the display list. So the first function that we use, OpenGL function, that is used to create the display, or you can say to create the different IDs corresponding to the display list. As we all know, different display lists should have different unique identification number. So how do you generate those unique identification number? Using the function gl gen list. So gl gen list is a function which is used to create or assign different IDs, to return the range of IDs for the display list. Next is GL new list, which is a function to create the new display list. It is similar to creating a new file, okay, creating the new display list, but remember a unique identification number should be assigned now for newly created display list. Next, GL call list is the function which is used to execute this, so which is used to call this newly created display list. Remember, you have to use this call list only after new list. So new list can be called only after GL gen list. So this is an order, okay. So while calling the display list, you have to specify the proper ID or the name of the display list as a parameter. Next, you have GL delete list. You can delete the created display list. So for deleting the display list, you have to properly pass the index, you have to properly pass the ID of the display list that you have to delete, and also you have to pass the number of display lists that you want to delete. So if you are passing the range of display list that you want to delete, suppose I have a range of display list that is already created, several display list if I have already created, then that range you can specify here as a parameter, and also you can pass the number of display list that you want to delete. Then finally, GL end list. End list is the one which will end the created display list. So this GL end new list and end list should come together. So after creating the display list, you have to end that list without forgetting. Here is an example of the display list creation. So as we have already seen, the very first function should be GL gen list. So what is this GL gen list? So here, for which you have to pass a range of number. So here I have passed a range. Instead of passing a range, I've just passed the number 1. What is the meaning of that? I want to generate only one display list whose ID is equal to 1. So here I'm going to store that integer value in a variable called index. So instead of 1, I can also pass here 10. So what is the meaning of that? 10 indices I am expecting. So out of those 10 indices, like maybe using those 10 indices, 10 different display lists I can create. Okay, so this is nothing but the range that you pass as a parameter. So many IDs will be created, and remember, index is the one which will always store the base index, base ID that is created. So if I'm specifying a range as 10, always the first display list ID would be starting from 1. Then the contiguous numbers are generated. Okay, 1 to 10. So the first ID that is generated when you call GL gen list is 1, which is returned here and saved it in the integer called index. Okay, so here index is equal to 1. So here, because the range is equal to 1. Next, I'm going to create here the display list. So what is the OpenGL function to create the display list? It is GL new list. And remember, the first parameter that you pass is the ID of the display list. So where is the ID saved? It is saved in the variable called index. And here I have the next parameter, GL compile. What is the meaning? Store this particular display list in the memory. So you don't have to execute it immediately. You can just store this, create and store it in the memory. So that is actually the meaning of GL compile. And then you can add the snippet, whatever the primitive that you want to create or that you want to store it in this display list, you can add here. So here I'm going to store the triangle primitive. So what are the 3 I require compulsorily 3 vertices if I'm specifying the primitive as triangles. So what are the 3 parameters that you pass, or the 3 functions here? GL vertex 3fe. Here remember, I'm passing the first vertex, which is nothing but an array here, and whenever I'm using array as a parameter, I must pass a vertex pointer v. Okay, so it's a 3D vertex I'm plotting through GL vertex 3fe function. Then next GL vertex 3fe, the next vertex v1, and the last vertex v2. So the 3 vertices I'm passing in order, which will draw a triangle for me, one triangle for me. Okay, and after that I will end the list of vertices. So this is a code snippet that you add into the display list, and remember, you have to end the display list here. Okay, and this is the only display list I'm creating. Suppose here multiple display list you want to create, you can specify a higher range and you can continue here. After end list, again you can create a new display list called GL new list, and again you have to pass the ID there, comma GL compile. So how you are going to pass the ID there? You can write index plus 1 or index plus 2, something like that. Index acts as a base there, so base plus 1, base plus 2, that way you can add the integer value to the index, and that is how you can create the next new display list. So you can go on creating the display list. And now once multiple display lists are created, next if you want to draw that display list, you want to call that display list, execute it. So what you have to do, you have to call a function gl call list, and remember the gl call list, when you're calling, you have to pass the id of the display list. Here the id of the display list is stored in the variable index, so you can directly pass index. Suppose multiple display list if you want to call, if you want to draw, then you can write this within a loop. So if I am passing 10 as a 10 display list, if I am creating, you can use a for loop there, which will iterate 10 times, and here you can increment the index so that this call list will be called this call list will be called 10 times. Okay, so all 10 display list would be executed here. Suppose if I want to delete any display list, I can use the function gl delete list, and here remember what I'm passing, the first parameter should be always the id of the display list. Here the id is stored in index, and this is the only id that I have. I can directly pass it, comma, the number of display list. How many display list I want to delete? It's only one. So here I can also use multiple display list deletion, so for which you have to pass the proper id, or the range of id you can pass as a parameter here. So I can pass like index plus 5. So what is the meaning of that? Base plus 5. That means total 5 display list I can this is a range that I'm specifying, so total 5 display list I can delete. So comma 5 you can pass, how many number of display list you want to delete, so those many you can just specify as a second parameter. So here the gl delete list is the one which will delete the newly created display list. So this is a simple example for demonstrating the generation of display list id, and then the creation of display list, then the execution of display list, and then finally deleting the display list.